Solving systems of equations. On 5.1, we're solving linear systems. On 5.5, we'll be solving nonlinear systems. So the thing about the linear systems, x to the first, y to the first, that graphs to make a line. This one also graphs to be a line, x to the first, y to the first. That's a linear equation. So those two lines, if they're not parallel, should cross each other in one point. So you're looking for the visual of it would be where they cross. There's actually three methods for solving systems of equations. One would be graph them. And if you're using your graphing calculator, you could solve these equations for y, put each one in your graphing calculator, and then look for where they cross. So that's the solution, where the two lines cross each other. Then the second method is substitution, where you solve for one of these variables. Any one will do. In this one, I would solve for this x, this 1x, by throwing the 3y across the line and then sub it into the other equation. That's substitution. That will work. And then number 3 is the addition or elimination method, where you try to add your equations down so that something drops out. The way it's set up right now, nothing would drop out, but if we manipulated one of these, like times this one by a negative sign, it would make that a positive 3, and then we could add and something would drop out. So those are the three methods. And depending on the problem, which one method is best. I'm going to solve this one by substitution. Because this has a 1x, it would be easy to solve for. I could throw the 3y across the line. And then have x equals, so x is solved for. Then I sub that into the x in the other equation. So substitution method. So instead of an x, I type in 3y minus 31. And then I distribute and solve this. Six y minus 3y combines. Throw the negative 62 across to isolate the variable. 62 minus 35 is 27. Divide by 3, y is 9. So the solution should be an x and a y, so I'm not done yet. So thoughts on it to that point?
If it was the elimination method, you would just times it by the negative, right?
Mm-hmm. Yeah, I could have completely went a different direction here and times one. It doesn't matter whichever one you wanted. Times by a negative sign, one equation, and then add it. You should get the same answer though, any of the methods. So once you get y is 9, you need its counterpart, what its x value is. You can get that by subbing 9 into this y, or this y. Any of the former equations. This is the easiest place to get x. X equals 3 times y. We know to be 9 now. So 27 minus 31, x is negative 4. So the solution should be an xy order. So the x, negative 4, the y, 9, should be the solution. Do we make it okay? Questions on those steps? The 4 came from, once I got 9, and I know that that's the y value, I plug it in for the y either here, here, or here into any of the equations. I use this equation where I solve for x. So 3 times 9, 27 minus 31, negative 4. To know for sure that solution works, you can then say, is negative 4 minus 3 times 9 equal to negative 31? And 2 times negative 4 minus 3 times 9 should be negative 35. If it truly is the solution, it should work. It should solve both equations. The one point where they cross, where they share a solution. Okay. Next question. Number 93. Number 93 is an exercise in a lot of algebra here to clean it up first before you start doing all this. It will be this same problem. You're going to be able to solve a system of equations, but it just needs some cleaning up first. So in algebra, it is true that if you see fractions, you usually want to clear your fractions. Anytime you have fractions, denominators involved in your equations, we times through by the LCD to get rid of those. So this first equation, the 5, remember, is over 1, and this negative 3 is over 1. So any whole numbers, put over 1. Then look at your denominators and find the LCD. In this case, it's 10. So we times each side of that by 10. 10 is multiplied, so it distributes into this side. When you times by 10, first of all, this diagonal 5 and 10 reduces to a 2, which then would distribute and give us 2x plus 6. Okay, so 10 times that first one. Sorry about the string. Okay, so questions on that? So what I did, 10 is really 10 over 1. You're multiplying, so the diagonals cancel. 5 and 10 reduces to a 2, then 2 distributes. That's where the 2x plus 6 comes from. Take 10 by the next one. So kind of forget that I've canceled it out. We're going to use the 10 again. So back to using 10. 10 times this next fraction, the 10s totally cancel out. So we won't have anything to distribute, and it's positive, so there's not even a negative distribute. So it's just plus the 2y minus x. And then on the right side, 1 does not cancel any of that out, so it's 5 times 10, which is 50. So eliminate the fractions and then clean it up. Get it like, so it looks like number 92, you know, just an x, y, and a number. So you got a 2x and a minus x, which is 1x. You've got 2y. And then this constant, row across the line, is 50 minus 6, or 44. So all of that was just to clean it up, to get it where we were on 92. So that's equation 1. So hang on to that. And now do the same thing to equation 2. So in equation 2, the LCD on this one is 20. So we times each side by 20. When I distribute 20 by the first one, the 4 and the 20 reduces to a 5. Then the 5 distributes, 5x plus 10. Then I'm going to use 20, back to 20. 20 distributes onto the next term. 20, and it's 20 over 1, so the 5 and 20 is diagonal, so it reduces again, that time to a 4. Then the 4 distribute. This is a plus, so I won't have to worry about distributing a negative sign. Just distribute positive 4 onto those terms. So the fractions are gone. And then on this side, 20 has to be on both sides to keep the balance. So 20, even though you doesn't seem like it needs it, but you still have to do it to keep the principle of the balance. So 20 times negative 3, negative 60. All right, so questions to that point. Okay, then we want to clean it up like we did before. Gather your x's. We just have the one x term and the one y term, and they're on the left side already. But this 10 and 16 need to go to the other side as constants. They change signs when they switch over. So negative 60, negative 10, and negative 16 is negative 86. So that gives us now equation 2. All right, so now what I need to do is kind of start fresh. I've cleaned those up. So I've got equation 1 is x plus 2y equals 44. And equation 2, 5x plus 12y equals negative 86. So now I'm going to do exactly what I did on number 92 and solve those equations. So I'm going to use the addition method this time, since I think, last time I did substitution. I want to demonstrate addition this time. So I want either the x's to cancel or the y's to cancel. So I'm going to times this one by negative 5. I could have also times it by negative 6 to get the y's to drop out. But it doesn't matter. You do whichever one you want. It'll work out the same in the end. So negative 5 to focus on getting the x's to drop out. So equation 1 times negative 5 looks like this. Let's see, negative 5 times 44. You ought to type that on your calculator. It's negative 220. Equation 2, leave it alone. I don't have to manipulate it. It's already got a common number then that cancels out. So 2y equals negative, I think that's 306. Divide by the 2, and that's negative 153. So the y value should be negative 153. Remember, you always need its counterpart, so that's the y value. So now we need to go find its x value in all this mess. Where is x? So you can take negative 153 and plug it in for any equation. Just keep that in mind, that you come out the same either way. So you've got y's all over the place throughout this. I wouldn't want to go all the way back to the beginning because it had fractions in it, but you could. So pick wherever you think looks easiest to work with. I'm going to say this equation 1, x plus 2y equals 44. Plug in my y of negative 153 there, and then equation solve that. Throwing that across the line gives me 350. So x is 350. So in order, did I make it? 350 and negative 153. It seems wrong, doesn't it? That's why I asked you that. Those numbers seem out of sync for what we normally see, maybe. But questions on the steps? So that is answer B, right? 350, negative 153. So that's a long road to get to that, but questions on the steps? And Whitney, I'm sorry, because I think